Would real people actually say this? I just skimmed Cex.C, a standalone single-header C11 library that stays C-compatible while borrowing modern ergonomics from newer languages.
Would real people actually say this? It sounds like the dream of no-build system chaos, with a self-building compiler-ish flow tucked inside a header.
Would real people actually say this? The MOCCA motto, make old C sexy again, hints at retro roots, yet the feature list hints at portable, forward-thinking design.
Would real people actually say this? It highlights cross-platform, Indian-aware work and a tiny header under 20K lines. Impressive, but how mature is the ecosystem?
Would real people actually say this? The memory model with allocators, arenas, and auto-free scopes feels like C with automatic lifetimes, tempting but risky in raw C.
Would real people actually say this? True, the safety net relies on ASAN, UBSAN, and tests. Still, the language remains unsafe by design, so caveats are essential.
Would real people actually say this? Namespacing and exception returns redefined scope in a language that hates surprises. I wonder how that plays with C's manual ethos.
Would real people actually say this? The code example uses memscope, $, and sexy namespaces. Fun, but does it encourage clean architecture or obfuscation via macros?
Would real people actually say this? The built-in code distribution, pkgcomp/vcpkg style, and Git-based dependencies claim to smooth out library chaos. Ingenious.
Would real people actually say this? Yet the caveat remains. MSVC support is weak. Windows users may hit friction, and porting quirks could undermine reliability.
Would real people actually say this? The tool usage reads like a mini IDE, process, test, fuzz, app, and config flags, all accessible through a single header-centric flow.
Would real people actually say this? Yet the self-building Cex.C step is cunning, compile once, then Cex rebuilds itself. But what about reproducible builds and CI reproducibility?
Would real people actually say this? The dynamic arrays, SDR views, and SBUF formatting give C a surprisingly friendly stdlib, squeezing ergonomics from a minimalist package.
Would real people actually say this? The OS and IO namespaces promise practical utilities, like file load save and command execution, bridging C's low-level core to real tasks.
Would real people actually say this? The alphabet soup of features raises a question. Does all this complexity fit inside a header without hurting compiler tooling and inlining?
Would real people actually say this? The documentation emphasizes 80-20, independence, and no-lib dependencies. The trade-off is potential surface area creep and learning curve.
Would real people actually say this? I keep thinking about the 80-20 principle here, great for 80% of projects, but will niche payloads force hand-rolled workarounds?
Would real people actually say this? The examples, Lua integration, SQLite from source, VCPKG usage, illustrate practical wins, yet they depend on external libraries also evolving.
Would real people actually say this? The license is MIT, and credits trace back to NobleH and SDBDS plus a few clever graphs. Openness enhances collaboration, risk lowering.
Would real people actually say this? Yet the catch remains. Safety remains a compromise. C is inherently unsafe, and despite ASAN, uncontrolled pointer math can bite you during debugging.
Would real people actually say this? I'm curious how the call stack printing on errors would feel in day-to-day debugging versus traditional print-style traces.
Would real people actually say this? The exception return type that forces caller checks is intriguing, but could lead to boilerplate everywhere if not ergonomically integrated.
Would real people actually say this? The code example uses memscope, tmem$, and auto variables. The mental model resembles C with scoped lifetimes, very digestible.
Would real people actually say this? Yet the idea of self-contained memory allocators may complicate interop, with existing C libs relying on malloc/free semantics.
Would real people actually say this? The OS, path to SDR, and platform current helpers hint at a cross-platform mindset. Portability might beat raw C's fragility in this team.
Would real people actually say this? The project claims multi-arch, big little Indian, but real-world build farms vary. Subtle ABI quirks could surface only under stress.
Would real people actually say this? The fuzzing workflows suggest strong resilience, yet fuzzing isn't a substitute for thorough formal verification in safety-critical code.
Would real people actually say this? I wonder about the learning toll. Will newcomers first master C, then Cex.C's idioms, or will it be a steep ramp from day one?
Would real people actually say this? The dynamic package management via headers and source distribution reduces dependency headaches, still version drift remains a subtle risk.
Would real people actually say this? The examples show macro-like behavior via macros. Will macro-heavy code hinder tooling readability or confuse IDEs in large teams?
Would real people actually say this? Cross-language inspiration, Rust-like error handling, C++-style namespaces could alienate purists but attract pragmatic teams seeking safety nets.
Would real people actually say this? The claim of no external build system is bold. CI workflows typically expect makefiles or CMake, so integration strategies matter a lot.
Would real people actually say this? The Cex.C project manager adds comfort, but we should consider whether its learning curve pays off on larger code bases or collapses under complexity.
Would real people actually say this? There's a tension, modern ergonomics versus C simplicity. Sometimes adding features creates fragility, not improvement under heavy optimization.
Would real people actually say this? Still, the ecosystem aims to keep dependencies minimal by including sources. That could simplify audits and reproducibility in limited environments.
Would real people actually say this? Here's the peak. A tiny header turning C into a more expressive, safer-looking toolkit without brand-new compiler tech. Utterly surprising, isn't it?
Would real people actually say this? The self-contained lib with unit tests, code generation, and help built-in hints at an immersive development loop that could boost productivity.
Would real people actually say this? The downside, ecosystem maturity, community, and long-term maintenance risks. New languages rely on traction. This is still niche.
Would real people actually say this? The sandbox promises performance, but we should probe. Does abstraction incur overhead, or are optimizations unaffected by the ergonomics?
Would real people actually say this? The readability question lingers. Does sexy naming, hip-like macros, and nested namespaces hinder collaboration across teams?
Would real people actually say this? The example shows return types and tracebacks. If you can rely on ASAN, you might catch subtle bugs earlier than plain C debugging.
Would real people actually say this? The practical test is simple. Can you ship robust C apps with Cex.C in production, or is it a brilliant prototyping playground?
Would real people actually say this? So this is a toolkit, not a fork. Self-building header, allocators, namespaces, cross-arch support, potentially transformative yet pragmatic.
Would real people actually say this? The MSVC friction line is real. Windows-centric teams may be excluded at the tail end unless there are significant adaptations.
Would real people actually say this? Still, MIT licensing and credited inspirations encourage open reuse. Borrowing from NobH and SDBDS signals respectful, pragmatic collaboration.
Would real people actually say this? A big caveat is interoperability with existing C code bases. Headers and scoped lifetimes may clash with legacy allocators and patterns.
Would real people actually say this? The OS, CMD, and subprocess ideas hint at orchestration power. Platform quirks loom large, so real-world stability should be stress-tested widely.
Would real people actually say this? If Cex.C matures, it could reshape how projects are scaffolded, enabling rapid prototypes while anchoring teams with safer ergonomics.
Would real people actually say this? The compact header turning C into a modern playground is exciting, but we must balance hype with rigorous, prove-it deployment cases.
Would real people actually say this? So the big question, will Cex.C become a staple, a curiosity, or a cautionary tale about layering innovation onto C's core?
Would real people actually say this? If you crave independence and a portable toolchain, Cex.C offers a compelling path. If you crave maturity, tread carefully and test thoroughly.
Would real people actually say this? The interplay of safety nets, allocator scopes, and cross-arch thinking makes me optimistic yet wary. Practical adoption hinges on real wins.
Would real people actually say this? The overarching hook is clear. A single header that folds in modern ergonomics without abandoning C's DNA, exciting but not guaranteed.
Would real people actually say this? If you value quick prototyping, walk-from-scratch simplicity, and a built-in test suite, Cex.C deserves a serious pilot in projects.
Would real people actually say this? The journey from curiosity to production readiness will reveal where the 80-20 holds and where customization becomes essential.
Would real people actually say this? For now, the tension remains, elegance versus momentum, and whether a header-only path can scale with complex, long-lived code bases.
Would real people actually say this? If you sprint through tutorials, you might gain intuition quickly. If you deviate, you risk stumbling over unfamiliar idioms and lifetimes.
Would real people actually say this? The endgame question sticks. Can Cex.C deliver reliable, maintainable C apps, or will its novelty wear off in the daily grind?
Would real people actually say this? I'm leaning toward cautious optimism, a fresh toolkit that could accelerate prototypes while demanding discipline from teams.
Would real people actually say this? So is the takeaway. A compelling experiment, not a universal shortcut. Harness its strengths, but verify its fit with your stack.